Good day, everyone. Our topic is all about constitutional isomers. So, what is constitutional isomers? Constitutional isomers, also called structural isomers, are compounds that have the same molecular formula pero lain-lain ang pagkakabit sa ilang mga atoms. Meaning, pareho sila og numbers of atoms but different ang arrangement or connectivity. Maunang mahimong lain ang properties sama sa boiling point, melting point, solubility, o reactivity. So sa simple nga pagka-istorya, same formula but different structure. For example, compounds with carbon 6 hydrogen 12 or carbon 5 hydrogen 12 can exist in more than one form depending on how the carbon atoms are connected. So nata example ana. And ang constitutional isomers is na siya tulo ka types. The first one is skeletal or chain isomers. Sunod ka positional isomers or rejoice isomers. And the last one is functional isomers or functional group of isomers. So each type differs in the way the atoms are connected, but all still share the same molecular formula. Ang pinaka-importante, dili pareho ang bonding pattern, bisag pareho ang formula. So atong the first types of sa ato ang constitutional isomers is the skeletal isomers. Also called chain isomers are isomers that differ in the arrangement of the carbon skeleton. Sa madaling salita, lain-lain ang branches sa carbon chain. This happen mostly in organic compounds with longer carbon chains because carbon can form different backbone shapes. So example ani is the pentane. Pentane has the molecular formula carbon 5 hydrogen 12, but it can exist in three chains forms. Ikaduha is N-pentane. Straight chain formed with 5 carbon atoms in a row. Dili siya branch. Isopentane, also called 2-methylbutane, the main chain has 4 carbons with 1 branch in the second carbon. Neopentane, also called 2,2-dimethylpropane, the main chain is only 3 carbons and there are 2 methyl branches in the second carbon. So why they are different? Even if all 3 have the same formula, their shapes are not the same. Ano man? Ang straight chain N-pentane mas elongated, while neopentane is more compact and highly branched. This affects intermolecular attraction, so branched molecules usually have lower boiling points than straight chains ones. So, simple comparisons, in pentane, less branch, more surface contact. Isopentane, moderately branched, neopentane, most branch, most compact. So in physical behavior, the three are not identical. This is a good example showing that molecular formula alone does not tell the whole story. Positional isomers. Positional isomers differ in the position of a functional group, double band or substituent in the same carbon skeleton. Pareho ang backbone pero lahi ang pwesto sa functional group. This type is common in alcohols, alkenes, and substituted aromatic compounds. Example, pentanol. Pentanol has the formula carbon 5 and hydrogen 12O, and a hydroxyl group or OH can be attached at different positions along the straight carbon chain, either sa first or sa end. So, pentanol 1. OH group is on carbon 1 at the end of the chain. Pentanol 2, all alcohol group is on carbon 2. Pentanol 3, OH carbon is on carbon 3. Why the position matters? The position of the alcohol group changes the molecule's polarity, shape, and sometimes its reactivity. For example, pentanol 1 alcohol and pentanol 2 alcohol may react differently in oxidant reaction because the alcohol group is attached to different kinds of carbon atoms. Sa practical sense, ang position sa functional group can affect how the compound behaves in chemical reactions and in biological systems. Positional isomers have same molecular formula, same functional group type, same carbon skeleton, but different position of the functional group. That small change in position can produce noticeable differences in chemical and physical properties. Functional isomers have the same molecular formula but belong to different functional groups. This means that the atoms are connected in such a way that the compound becomes a different class of organic compound. Mao ni ang mas obvious nga kalainan because the chemical behavior can change greatly. Example 1-hexane and cyclohexane. Both 1-hexane and cyclohexane have the molecular formula carbon 6 hydrogen 12, but they are not the same kind of compound. 1-hexane is straight chain alkane with 1 carbon-carbon double.